Hello all, I am Jairam in a series of providing video sessions on C programming language. In my last session, in my previous session, I have discussed about union, what is meant by union, what is the syntax of union, how we can declare unions. So these concepts are discussed in my last session. If you want that session, please subscribe my channel Jairam Tulapati and like my videos. Now, in this session, I am going to discuss about what is meant by Bitfield concept. What is the importance of Bitfield concept in C programming language? Bitfields. Suppose the Bitfield concepts came into existence, or we often use this Bitfield concept in structures. Why? Because suppose structure stores data items of different data types. Structure stores data items of different data types. So, while storing data items of different data types, there may be a chance. There may be a chance in order to store the data. Suppose, let's here I have written some points here. Before going to actual definition of Bitfield, first see the point I have written here. Suppose your C program contains a number of true or false variables grouped in a structure called status. Okay, true or false variables grouped in a structure called status. This is the syntax of struct keyword structure. Unsigned integer, I have taken two different type of integers of unsigned, and width validated with height validated. These are the two different type of variables. And next here status. This structure require 8 bytes of memory space, but in actual we are going to store either 0 or 1 in each of the variables. The C programming language offers a better way to utilize the memory space in such situations. What this point means here, the character length of integer is 4 bytes. Here take 4 bytes of length. Here I have written two statements, that's why it going to take to 8 bytes of data in memory location. Okay, that's fine. Next, suppose we are going to store either 0 or 1. Suppose if I want to store either 0 or 1 in these variables, normally this width validated and height validated of type integer type, so these are going to take 8 bytes of data. That means 4 plus 4, 8 bytes of data in memory location. Now I am going to assign. Now I want to store either 0 or 1 values in these variables of integer type. So how can I store? Is there any way to store those 0 or 1s in those type of integer values? Yes, there is a way. There is a way to store those type of 0 or 1 values into integer type. The way, how can we store? Here, the C programming language offers a better way to utilize the memory space by reducing the integer type, or by storing by reducing the number of bytes, we can store the memory location, memory space as well. So it is good for the programmer, or good for the compiler, execute very fast, and is the main feature of the readability concept came into existing here. The program readability is also very good. The compiler understand the line by line executed without any error, and that executed program to going to take very less much of space. Next, understand next point. If we are using such variables inside a structure, now I am going to assign 0 or 1 to those integers. Then you can define the width of a variable. The width of a variable, which tells the compiler you are going to use only those number of bytes. For example, the above structure can be rewritten as follows. That means by using width, there is a there is a variable in the bit field called width. By using this width variable, we can tell the compiler which variable I am going to use and how many number of bytes I am going to use, how many number of bytes the union going to take in the memory location. So by taking into consideration or by using the width variable of the bit field, we can specify or the union specify or we can specify the how much memory the variables declared, the members declared inside the structure going to take. So here let's understand here, this example is rewritten here. Let's understand this example here. Here by using structure same, why the change here is, here I am assigning the values. These values are called flag values. Flag means either true or false. Here by using the width variable of bitfield concept, here I am assigning those values as 1 and 1. That means these values take, these width validate and height validate variables take only 1 byte of data in the memory location. So the space is also saved, the program readability increases, and it is a very easy for the compiler to execute the program. At the same time, readability of the program is also. This is the main use of the bitfield concept in the structures. Let's understand the program in detail with the help of a program. I have written a small program in C programming language. Here I have included in the two basic header files. Here I am included the string header file too. Why? Because here I am using some type of strings, that's why I am using the string data file. And next here I am taking those structure example I have written here. Struct unsigned int width validated, unsigned int height validated. Next here the status variable by using the size of function, we are going to find the what is the size of the structure, how much size the structure is going to take, and how much size the structure, how much memory space this structure is going to take. We can get that example, we can get that value, that memory location, or that memory location how much space this structure going to take by using the status variable. And there is a function called size of function. By using the size of function, uh, passing the status and a parameter to it, we can easily identify how much space the structure or the members are defined in the structure going to take. So let's understand the program here. Structure, I have written a structure here. Next I have defined a structure with bit field. Here I am declaring the bit field by using the width variable in the bit field concept. Here I am declaring the values as 1 1. In the structure I haven't declared any value, and here by using the status variable I am making this as status 1, I make it as status 2. Just I am checking the status by using the size of operator in the C program language. How much space these structure members going to take in the memory location. So here I have written main method. Just I am printing memory size occupied by status 1. That means the members of the status. How much space by using the size of function. I am just passing the status 1 name to the size of function, and this passing status with two variable to the size of function as an argument. Then I am printing the output. Then I am just printing by using status variable. I am just printing how much space the members of the union going to take. Here this is the output. Observe the output once. Memory size occupied by status 1 is 4 bytes. Memory size occupied by status 2 is 1 byte. Why? Because observe the program here. Observe the members of the status 1 first. Here I have declared two integer types. Integer, normally integer take 4 bytes of data. 4 byte of data. That's why here the 4 bytes of data is printed here. Here I have already assigned a bit field value. That means here I am assigning a flag value to the members. to the union members are data items of the structure. Thus why here the values, the flag values, here I have declared thus why the data item values of this structure is printed of 1, printed as 1. This is the example on how Bitfield concept is very useful. Why Bitfield concept is very useful in structures. Next, Bitfield declaration. How the Bitfield declaration goes here in structures. In C programming language are the concept in structures. Here by using the struct keyword we can type the, by using the struct keyword start the where we included the Bitfield concept into C program language, and next here type what is the type of that Bitfield and member name of that field, and next is this width. By using this width we can define the memory location of that variable, how much memory the memory bytes we are keeping, that specifies, that width specifies. By using that width variable we can assign value to the particular member, how much value the member of a particular structure going to take in the memory location. Next, here type specifies an integer type, determines how a bit field value is interpreted. The type may be signed int or unsigned int. Here type means here generally in the structure type an integer. Either straight type may be either a integer type, signed int and unsigned int. Next, member, Bitfield member, the name of the Bitfield. The member name specifies the name of the Bitfield. Next, width. Here the width specifies number of bits in the bit field, how many bits the member of the structure going to take in the memory location. The width must be less than, here please note this point, the width must be less than or equal to the bit width of the specified type. Why? Because here suppose I have written width as 3. Suppose I have taken width as 3. Next I have taken data type of integer type. Next here by member name I have written member name as some data. Int data colon my width value I have taken here is 4. Suppose here let's read the point again. The width must be less than or equal to the bit width of the specified type. Here what is the value of the width I have taken? 4 bytes of data. Next, what is the type of data? Actual type means integer type. What is the value, what is the actual length the integer going to take memory location? 8 bytes of data. Here width variable value is 4 bytes and the integer data type value is 8 bytes of data. So width value is less than 8 bytes of data. That is the point. We have to note it here. The width variable value must be less than or equal to the bit width of the specified type. This is the type. Okay. Next, here I have written a small program on Bitfield. Let's understand the program. Here I have included the basic header files, and next one is I am included taken the string header file too. Next here structure. By structure here I have taken a of integer and unsigned int type. That's why here I am assigning the width value as 3. My width value is 3. Next, I have written main method, and here the status variable. This is called status variable of the structure. By using this status variable, I am now calling the members of the structure. Age equal to 4. I am just printing size of age. I am just printing the size of age onto my output screen. Here the size of age is 1. Why? Because here the age value generally takes how much of memory location here. Here it takes only 1 byte of data. That's why here the value, by using the size of function, I am printing the value as 1. Next printf statement is age. Next printf statement is age. by using this by using the status variable, i am now calling the I am now calling the member of this structure, age. Age.age equal to 4. Just I am printing that age.age onto output screen. That's why here age.age is printed as 4 in my output screen. You can observe the output on the right side of your program. Next here I am assigning age.age equal to 7. That two value just I am printing on my output screen. Age.age equal to 7. That two printed very well without any corrupt. Next I am assigning age.age equal to 8. But the value printed here in the output is 0. Just see the difference. Just understand the difference here. I am assigning the value age.age equal to 8. By using the status variable of the structure, I am calling the age variable. That's why I have written age.age and assigning 8 value to it. What is the width value? Width value is 3. What is the type of that width value? What is the type of that width? Integer type. Generally integer take how much of memory in the memory location? 8 bytes of data. Then here how much value I have assigned here 8. So 8 equal to 8. That's why the value corrupted. The value misplaced. That's why that's why the difference here, you can observe the difference here. Age.age is equal to 0 printed on my output screen. So this is the main concept of the width. This is the we have to understand why importance of width variable. The point here to be noted, here is the width variable. Here the width is 3. Here the width variable value is 3. It must be less than the width of the data type. It must be less than width of data type. That means here I have assigned 8 value, and the value here assigned is 3. That must be less than with the data type. Otherwise we get misplaced value, otherwise our correct value onto output screen. That's why here the age.age is printed as 0. So this is a small program on Bitfields. So this is the importance, and this is the mainly used concept, and this is the way the members of the structure you going to take memory in the memory location. In this class, in my upcoming session, I am going to discuss about what is meant by type def, what is the importance of type def, how the type def function going to execute, how we use type def function, how the programmers going to execute, how the programmers included type def function into their program. So this topic I am going to discuss in my next session. If you like this session, please like my channel and subscribe my channel and like my videos. Comment here for your any doubts and suggestion. I shall answer your doubts without any fail. Thank you one and all for watching. Thank you all.